In 1998, a woman named Carol bought a Maytag top loader with an agitator, a mechanical timer, and a steel transmission. It filled the tub all the way. It washed her clothes in 45 minutes. It ran for 22 years without a single service call. Then she replaced it with a high-efficiency Samsung front loader. 3 years later, the bearing seized. The repair estimate was $1,400. The machine cost $1,100. The repairman looked at her and said the 5 most expensive words in the modern economy. It is not worth fixing. Carol is not unusual. She is the norm. We have spoken to appliance technicians across the country. We have gone through Consumer Reports reliability surveys covering more than 100,000 machine owners. We have read the engineering teardowns on iFixit. We have reviewed the Department of Energy rulemaking documents, and every single source points to the same conclusion. Approximately 80% of the high-efficiency washing machines built after 2015 will fail within 3 to 7 years. The machines that replaced them, the pre-2007 agitator top loaders, were lasting 15 to 25 years. A Norwegian appliance study put the actual numbers on paper. The average pre-HE machine lasted 19.2 years. The average post-HE machine lasts 10.6 years. That is a 45% decline in lifespan, and the machines keep getting more expensive. Today we are going to open up the modern high-efficiency washing machine and show you exactly what is inside it. Not marketing language, not energy ratings, components, materials, failure modes, and the repair math that proves you are not imagining it. The story starts not in a factory, but in a government building in Washington. In 2007, Congress passed the Energy Independence and Security Act, which directed the Department of Energy to update its standards for residential washing machines under the Energy Policy and Conservation Act. By 2015, the DOE's updated standard was fully enforced, with a second tier following in 2018. What the regulation required was a water factor at or below 6.5 gallons per cubic foot of drum capacity for top loaders. The machines your parents owned used approximately 40 to 45 gallons per load. The new machines use a fraction of that. Now, reducing water use sounds like a reasonable goal. The problem is that water is not just a cleaning medium. Water is the mechanical force that drives the wash. It suspends the detergent. It carries the soil away from the fabric. It provides the thermal mass that makes a hot wash actually hot. When you mandate less water, you mandate less cleaning power. And when you mandate less cleaning power, engineers have to compensate somewhere. They compensated with electronics, sensors to detect load weight, digital water level controls, variable speed motors running hotter and harder than anything in the previous generation, longer cycle times to make up for reduced mechanical action. A machine that used to finish in 45 minutes now runs for an hour and 40. That is not efficiency. That is the same job done worse, over a longer period, by a machine that costs more to build and less to run, measured only by the narrow government metric that ignores everything else. They call it Energy Star certified. We call it a machine that cannot clean your clothes on the first try. And the evidence is in the fact that manufacturers eventually had to add a deep fill override button. They put a button on the machine that lets you add more water than the regulations recommend, because the complaints were so loud and so consistent that they had no other choice. Think about that for a moment. The engineering team acknowledged through a hardware modification that their own regulated design was insufficient. And when you use that deep fill override, which most owners now do as a matter of routine, the machine uses more water per cycle than the regulations were designed to allow. In practice, you own a more expensive, less durable machine that uses exactly the same amount of water as the top loader it replaced. That is the regulatory trap. But the corporate trap is deeper. The DOE mandate did not just reduce water, it forced manufacturers to redesign machines from the ground up. And in that redesign, every decision that increased repairability, reliability, and service life was replaced by a decision that reduced manufacturing cost. The regulation gave the industry cover to do what it wanted to do anyway. Build cheaper machines with a shorter replacement cycle. Here's what that looks like inside the machine. The most catastrophic design decision in the modern front-load washing machine is the sealed tub bearing. In a pre-2007 top loader, the drum bearing was a standard ball bearing cartridge. It sat in a housing you could access with basic tools. The cartridge cost approximately $50 at any parts supplier. Replacement took a competent DIY owner about 2 hours. It was the kind of repair a teenager could learn on a Saturday afternoon. In the modern front-load, high-efficiency machine, the LG, the Samsung, the Whirlpool front-loader, the bearing is a polymer and needle hybrid assembly that has been injection molded directly into the outer plastic tub. It is not a separate component. It is permanently fused to the tub housing during manufacturing. That outer tub is a sealed unit. When the bearing fails, and it will fail. Between 3 and 5 years in, you cannot replace the bearing. You must replace the entire tub assembly. The bearing costs $20 as a standalone part, but you cannot buy the standalone part. The sealed tub assembly costs $800 or more from the manufacturer. Add 10 to 20 hours of labor at industry rates, and your total repair bill lands between $1,400 and $1,800. The machine you bought cost $900 to $1,500 new. The repairman looks at you and says it is not worth fixing, and the bearing fails because of a cascade of design compromises. The outer tub is no longer steel. Manufacturers switched to plastic on the outer drum housing years ago. The cost savings per unit is approximately $8 to $12, but plastic flexes under load in a way that steel does not. Every time that drum spins with a full load of wet laundry, that load weighs 200 to 400 pounds under centrifugal force. The plastic housing flexes slightly. That flexing puts cyclical stress on the bearing seal. Detergent residue from low water cycles accumulates in the bearing cavity. Grease leaks. The seal erodes. You start hearing thumping during the spin cycle. Then you start seeing water pooling under the machine. Then the drum goes out of balance and the machine shakes itself across the floor. Then the repairman arrives and writes you an estimate for $1,400. That sequence accounts for 25 to 35% of all high-efficiency washer failures, according to Consumer Reports data from 2025. It is the single most common catastrophic failure mode in front-load machines. But the sealed bearing is not even the most frequent failure. That distinction belongs to the main control board. The electronic control board is responsible for approximately 35% of all high-efficiency washing machine failures. Before 2008, a washing machine was controlled by a mechanical timer. It had physical gears, physical contacts, a spring-loaded cam that advanced the cycle. There was nothing to short out, nothing to overload, nothing to lose its firmware. You could rebuild a mechanical timer with a standard toolkit and a parts diagram. They lasted 20 years as a matter of course. The modern HE machine replaces that mechanical timer with a main printed circuit board populated with surface mount chips sourced primarily from Chinese manufacturers, a Wi-Fi module if the machine has smart features, and a proprietary firmware package that is locked by the manufacturer. The board is mounted at the rear of the machine in a humid laundry environment, subject to vibration every single cycle. Power surges crack the solder joints, heat cycling swells and eventually bursts the capacitors. The board fails after 2 to 4 years with an error code on the display. Samsung machines throw UE codes for unbalanced errors. LG machines throw OE codes for drain failures. GE machines throw a sequence of codes that may require specialized diagnostic software to fully interpret. Samsung and LG have moved toward proprietary diagnostic software that independent repair shops must pay to access. If the shop is not subscribed, they cannot access the full diagnostic capability for your machine. The board itself costs $300 to $500 from the manufacturer. There is no aftermarket replacement. The firmware is locked, so a third-party board cannot be flashed. To work in your machine, the manufacturer controls the entire parts chain. Labor adds another $150 to $200. Your total bill is $450 to $700 on a machine that may have cost $800. And if the board fails again 18 months later, which it frequently does, you are back at the same calculation. Now look at the drain pump. The drain pump impeller in pre-2015 machines was cast from glass-filled nylon. It was tough, dimensionally stable, and tolerant of the debris that enters every residential washing machine. Coins, buttons, small fasteners, bits of fabric. The impeller in the modern high-efficiency machine is thin injection molded plastic. The cost difference per unit is $5 to $8 at manufacturing volume. The impeller cracks, deforms, or jams under debris load. When the impeller fails, the motor it is attached to overheats and burns out. Standing water after the cycle ends is the first symptom. A continuous humming noise without water movement is the second. The repair runs $200 to $400. Parts availability from third-party suppliers is inconsistent because manufacturers discontinue components 3 to 5 years after a model's production run ends. Then there are the suspension rods and the high-efficiency top loader. The old design used metal springs to absorb drum movement during spin. Springs are nearly indestructible. They tolerate thousands of cycles without material fatigue. The modern HE top loader, the Whirlpool Cabrio, the Maytag Bravos, the LGWT series uses foam and rubber polymer damper rods instead. The cost savings are real. The durability is not. Under 500 or more wash cycles per year, normal for a family of 4, the foam degrades. The rods lose their damping capacity. The drum starts to walk. The machine vibrates violently enough to move across the floor and damage the surrounding cabinetry. Replacement requires substantial disassembly. Labor runs $300 to $600. And those rods, like the tub bearing, attached to a proprietary housing that makes the repair a removal and replacement of subassemblies, not a simple part swap. Add up the 4 primary failure modes: sealed bearing, control board, drain pump, suspension rods, and you account for more than 85% of all high-efficiency washing machine service calls. Every one of those failures traces directly to a material downgrade or a design decision that reduced manufacturing cost at the expense of service life. The motor tells the same story. The old top loader motor ran at approximately 40% of its rated capacity during a normal wash cycle. An electric motor running at 40% load generates minimal heat, experiences minimal wear, and lasts for decades. The direct drive inverter motor in the modern HE machine runs at 80% of rated capacity every cycle because the machine is trying to compensate for reduced water volume with increased mechanical agitation. A motor running continuously near its thermal and load limits does not last 20 years. It lasts 4 to 6 years. The replacement cost is $200 to $300, close enough to the machine's depreciated value that many owners simply replace the unit rather than authorize the repair. This is not an accident. This is arithmetic. The manufacturer sells a machine at a lower price point, saves $8 on the pump impeller, $12 on the tub housing, $40 on the bearing design, and $20 on the motor specification. Across millions of units, those savings are enormous. The cost is transferred entirely to the consumer in a repair bill that arrives just after the warranty expires, for an amount that makes repair irrational and replacement mandatory. The replacement cycle is the product. The washing machine is just the delivery mechanism. But the machine being designed to fail is only half the problem. The other half is that when it does fail, the repair system is designed to fail you too. The average age of a home appliance repair in the United States is in the low to mid-40s, and the field is not attracting new entrants at the rate it loses experienced ones. The pool of people who can diagnose a complex electronic control fault, access proprietary firmware, source a discontinued component, and perform a sealed tub replacement is shrinking every year. What is replacing those technicians in many markets is a parts swapping model. A technician arrives, reads the error code, and begins replacing boards and motors until the machine works or the customer stops authorizing charges. That is not repair. That is a process of elimination at the customer's expense. The industry has a name for it. They call it the parts cannon. Private equity firms have been acquiring local repair shops for years, keeping the truck graphics and the phone number and replacing the experienced diagnostic technician with a lower wage employee following a script. The service call becomes a sales pitch. The honest assessment, the machine is not worth fixing, becomes the path to a commission on a new unit. The repairman you call is not always the repairman you think you are getting. So what do? You buy the machines that are designed like the old ones. Specifically, you buy what the repairmen put in their own homes. The Speed Queen TC5 top loader is the closest thing available on the consumer market to a commercial laundromat machine. Speed Queen builds equipment for coin laundries, where a machine may run 10 loads a day, 365 days a year. The residential version is built to the same mechanical specification. It has a steel transmission with steel helical gears. It has metal suspension springs, not polymer rods. It fills the tub with enough water to actually suspend the load. The cycle takes less than 45 minutes. There is a mechanical timer option. There is no sealed bearing because the drum bearing is accessible and replaceable as a standalone component. Speed Queen rates the TC5 for a 25-year service life under normal residential use. That rating is backed by the same manufacturing heritage that supplies commercial laundries, where machines that fail get pulled from service and repaired the same day. The simplest Whirlpool top loader with a physical agitator, not the Cabrio, not the HE impeller model, but the basic agitator model in the $350 to $450 range, is still built with a serviceable transmission and accessible components. It is not as durable as a Speed Queen, but it is repairable. Parts are widely available. The design has not changed substantially in 30 years. A technician who trained in 2005 can still work on it in 2025. If you already own a washing machine from the 1990s or early 2000s that is still running, do not replace it. A working Maytag from 2002 is built with components that are categorically superior to anything available at retail today. Maintain it. Replace the hoses every 10 years. If the pump fails, fix the pump. It is an asset. It will outlast anything you can buy to replace it. The rule is simple. Count the failure points. Every sensor is a failure point. Every circuit board is a failure point. Every Wi-Fi module is a failure point. Every sealed assembly is a failure point. The machine with the fewest failure points will outlast the machine with the most features. This has always been true in mechanical engineering. It is just that for a generation, the appliance industry has been in the business of selling you the features and billing you for the failure points. Stop buying the touchscreen. Start buying the transmission. Stop paying for the energy savings that the machine cancels out in its first repair bill. Stop letting the warranty expiration date tell you when your machine is allowed to break. Buy the machine the repairman puts in his own home. Buy it once. Run it until the wheels fall off. And if you find a technician who can still fix things the right way, pay him what he is worth. There are fewer of them every year. And when they are gone, the only person left to tell you the truth will be the salesman at the appliance store.